Okay, now I already did a piece on how metals form ions. That was on the front of this worksheet. We're going to be looking at nonmetals now. So nonmetals are located in the upper right-hand corner of the periodic table, and that's going to be mostly tall group columns 5, 6, and 7. All right, so make sure you're on the non-metal side. And then once again, the first thing you're going to do when you decide how an atom is going to form an ion is figure out whether it's a metal or a non-metal. All right, now we filled in, you can fill in the definition of anion. It's just a negative ion. We filled in key points on the other side, which basically they're the same, except in this case we've got nonmetals, and nonmetals will always gain electrons to become stable. So why is that? Just like metals, they want an octet or a duet in the outer shell, but because they have more electrons in the outer shell already, it's easier for them to just gain a few more in order to get to what is almost always going to be an octet in this case, 8 electrons in the outer shell. All right, so our first atom is fluorine, and you just look up the element fluorine on your periodic table. It's right here, symbol is F, and the atomic number is 9, meaning that it has 9 protons. So we're going to fill in the protons, P equals 9, and put the symbol down, neutral atom. The symbol has no superscript, it has no charge. In this case, we have a nonmetal, and I already have 1, 2, 3, 4, 5, 6, 7 electrons in the outer shell. So I'm going to add however many electrons I need to get to 8 electrons in the outer shell. In this case, that's just going to be 1 more electron. So we're going to put 1 more electron in there. I'm just showing that, what's happening right there. And so here this will be a 1, and we are gaining in this case because we have a non-metal atom. All right, so we end up with what's called a fluoride ion then. That is a charged version of an atom. In this case, it has more electrons than protons. So all of the original electrons are still there. We don't, if we're a nonmetal, we don't lose electrons, we gain. All right, and then we have that 1 additional electron that was picked up probably from another atom, like a sodium atom. And now our protons haven't changed because protons never change. And so we've got 9 protons, but we have 1 more electron, right? So a total of 10 electrons. And when I set up my little calculation here for charge, it's always going to be protons minus electrons. So it's going to be 9 minus 10 is equal to -1. All right, then we have a negative number. And we're going to show that up here as the letter F and a -1 superscript. Okay. Next one. Oxygen also has 2 energy levels. This time it has 1, 2, 3, 4, 5, 6 electrons in the outer shell. So in order to get to 8, it needs 2 more electrons. So there's 1 coming in, and here's another coming in. All right, so symbol for, oh, I'm sorry, I didn't on the periodic table. Here we go. Here's oxygen. It's element number 8. All right, so we have 8 protons, and our symbol is the letter O. It is a nonmetal. It will gain 2 electrons. Then my oxide ion will have the same number of protons. Those can't change. And I'm going to have 2 energy shells now, like that. And so same electrons I had before, only this time I'm going to be adding those 2 additional electrons in. And of course you could just do them all in the same color or in pencil or whatever. I'm just doing it that way to make it more obvious what is happening. All right, so I've got 8 protons, and now I've got 2 plus my 8, so a total of 10 electrons again, just like I had here. only now I have 8 protons. So my calculation is going to be 8 minus 10, and our charge will be -2. So charge is determined by the balance between the protons and electrons, but the protons can never change, only the electrons. And we would write this as the symbol O with a superscript 2- to show that it is an ion. In this case, we call that an oxide ion. All right, now we'll go to some larger atoms. These are in the 3rd period because they have 1, 2, 3 energy levels. And if we count the electrons in the outside of chlorine, we have 1, 2, 3, 4, 5, 6, 7. So just like fluorine, we're going to have to gain an electron to get to 8. Chlorine is number 17 on the periodic table. It is right here. Symbol is Cl, so that's going to be P equals 17, 17 protons. Here's our symbol for a neutral atom. We have a nonmetal still, and we're only going to gain 1 electron. That's how we show it. Okay, over here our protons have not changed. And that means that our protons are 17, and we're going to have all of the original electrons plus 1. So I've got the first shell, which has only 2 electrons, the second shell with 8 electrons, and now a third shell that also has 8 electrons. So my total number of electrons is 18, and my charge will be space here, 17 minus 18, and that's going to be equal to -1. All right, so then to write my symbol, I'll write the atom symbol, which is Cl, with either a minus or a 1- after it. All right, we can do one more, but you can see when they have the same number of energy shells and they're not both nonmetals, they're going to end up in the same place. All right, we're just going to be filling up this outer shell. So in this case, we have 1, 2, 3, 4, 5 electrons in the outer shell. We're going to have to add 3 electrons in order to get to 8, and that is as high as we will go. All right, and I always pair them with those unpaired electrons. All right, so phosphorus is element number 15 on the periodic table, right here. Right, I'm out of focus, sorry about that. Let's see if I can get that to focus again. There we go. All right, phosphorus number 15 on the periodic table. So that's going to be P equal to 15. And our symbol is P. We've got a nonmetal, which will be gaining 1, 2, 3 electrons. How do I know that? I have to gain however many I need to get to 8 if I'm talking about a nonmetal. All right, my phosphide ion, the protons will stay the same. Then I'm going to add 1 energy level, 2, and let's see if I can draw a third. 3. There we go. All right, 2 electrons in the first level, then 8 in the second, and 8 in the third. And I'm just going to put in the red electrons to show the additional ones that were added, but once again, you don't have to change the color. All right, there we go. That's what it would look like after it picks up those 3 electrons. That means we had 15, or we have 15 protons. We gained 3 electrons, so if we got 2 plus 8 is 10, plus another 8, we have 18 electrons total. And so our calculation is going to be 15 minus 18 is going to be equal to -3. And so we would write the symbol as P3- for a phosphide ion. There you go. All right, so key point, metals lose electrons. They're going to lose whatever's in the valence shell and go down to the shell below. Nonmetals gain electrons. They'll gain however many they need to in order to get to 8. And charge is determined by the balance between the protons and the electrons.